All right, guys, this is going to be the first recording that I give you. So hopefully it all goes well, but honestly, I haven't thought too much about how to lay this out. The ideas here are pretty simple, but here's what I do want to say before I even get started. Well, first, I'm just going to start off with some vocabulary over here, but outside of that, guys, these problems are actually really easy, but they might take some time. So you can't be lazy in doing them, but they are easy. You just need to think a little bit about them, okay? And second thing, get a calculator. Get a calculator, and these problems become stupid easy because it really is punching numbers into a calculator at that point. You're truly comparing numbers. So you have to be patient with it if you don't have a calculator. So that's what this really is going to be focused on, is without a calculator. At the end of this video, I'm going to just show you how to type all this stuff into a calculator. But ultimately, this lesson is going to be on comparing real numbers, and those real numbers are going to come in multiple forms. So you're going to see fractions, percents, square roots, irrational numbers, many of different formats. Pi is one of them that you're going to see a lot. But here's where we're going to get started. Real numbers. Okay, so real numbers break into two categories. You have your rational numbers and you have your irrational numbers. And I'm just going to go over this very simply. Okay, so rational numbers are actually any number that can be written down as a fraction. So if you can take the number and write it in the format a over b, then it's a rational number. Okay, so this can get actually extremely abstract sometimes. So for example, if the number 1, here's an example. The number 5 is a rational number because it can be written 5 over 1. It can be written in fraction form. So the number 5 is a rational number, okay? So it's not as straightforward as just saying all fractions. It's any number that can be written as a fraction is a rational number. Now, let's make it even more simple. That's more of an exact definition, okay? So a very simple definition is if the number has a decimal that terminates or it stops. So for example, 6.225, and then that's the end of the number. It stops like that. That's a rational number. So if the number has a decimal that stops, it's rational. Another one is if the number has a decimal that is repeating. So for example, let's say 25, 25, 25, 25, and that's just an example, but it's just repeating over and over and over and over, and it keeps going on forever. That's also an example of a rational number. Okay? An example of an irrational number is just a number that has a decimal that doesn't repeat and it also doesn't terminate. All right? So pi is an example of an irrational number, 3.1415 ... and it keeps going, but it never stops. Okay? Other interesting examples of irrational numbers, the easiest way to find them is almost any square root, unless it's a perfectly square number. And what I mean by perfectly square is like the square root of 4. That's perfectly square because the square root of 4 is 2. The square root of 9 is perfectly square because the square root of 9 is 3. But anything that's not perfectly square, so for example, square root of 5, square root of 6, square root of 7, square root of 8, all of those in between that 4 and 9, all of these are irrational numbers. They will have decimals that go on forever. So for example, let me just type it into a calculator so I can show you. Second square root of 5. So it says it's 2.236067977, and just because it stops there doesn't mean it actually stops. That pretty much you can't fit. You see all these dots right here? There's no way you can fit all the decimals on this screen. The decimals literally go on forever and they never repeat the same order. So it's an irrational number. The square root of 6 is the same. The square root of 7. The square root of 8. Let's see if we can get off of that. The square root of 9 is a perfectly square number. The square root of 10 is not. It will go on forever. Okay? So square roots most of the time end up being irrational. Okay, so let's talk about how to convert some of these things in more understandable ways. So I'm going to start with percents, actually. So percents super easy, and that's why I wanted to start with it, because on the examples that I'm going to show you in a second, which are actually the ones from the pre-test we did earlier, on these examples you don't actually see percents, but you might on your homework assignment. So I'm going to show you how to convert those real quick. So percents, it's as easy as really moving a decimal point 2 places. Now let me explain why. So if I have 59% and I want to see that as an actual number, 59% is the same thing as 59. Look, the word per means divide. Per cent. So 100, like how many cents are in a dollar? 100. How many years are in a century? 100. So 59% is 59 over 100, which is the same thing as 0.59. So when they tell you to take a percent and to convert it into a decimal, move the decimal place twice, that's why, because you're actually dividing by 100. Okay, so for example, 1,000, let's do a weird one, 1,617%. How do you write that as a decimal? Well, written as a decimal is 16.17. Take the decimal place, move it twice, and that's percentages for you. Okay, one more really strange one. I'm just going to make it excessively large just so you can understand what I'm saying. 1,516,271.5%. Let's take this and write it as a decimal. Okay, so take the decimal place, move it twice, right there. So we're going to have 15162 decimal 715. So 1,516,271.5% is the same thing as 15,162.715. That's how percents work, okay? So on your practice, it's very possible that you're going to be having to convert percents into decimals. That's how you would do that. Square roots, very difficult without a calculator. Again, I can't stress enough that you guys just simply need calculators, but here's how I would use it on, if I did not have a calculator, this is how I would estimate square roots. So if I ask for something like the square root of 75, and to estimate a decimal for that, then what I would start thinking about is the perfectly square numbers that surround the square root of 75. For example, the square root of 64 is perfectly square, okay? Then the square root of 81 is also perfectly square. And the square root of 75 falls somewhere in between the square root of 64 and the square root of 81. So the square root of 64 is 8. Square root of 81 is 9. So if the square root of 75 falls in between the square root of 64 and the square root of 81, then the square root of 75 also falls somewhere between 8 and 9. Now let's get a little more precise if we can, and let's just think about halves, all right? So is the square root of 75 closer to 81, or is it closer to 64? So if this is halfway between 64 and 81, then the square root of 75 would find itself just a little bit on the right side of halfway. So somewhere over here, like square root of 75, maybe-ish, right? So that means it's probably going to be a little bit over 8. So it's going to be like, just to estimate, let's say 8.6. Now that's about the best you can do better than that, but as far as just general estimation, that's how you should do it. Let's find out real quick. Let's see what the square root of 75 is. Square root of 75, 8.66. Okay, so I got lucky as far as getting 8.6 even, but I knew that it was probably going to be greater than 8.5 because 75 is more than halfway from 64 to 81. It's a little bit bigger than half. So that means between 8 and 9, I know that the number should be a little bit more than halfway. All right, so let's do another one real quick. I wish I could have a student just that I could call a random student's name and you guys give me a number, but I'm just going to have to make it up on my own. So we'll do square root of, let's say, 55. This could be a tough one. So I'm thinking, all right, by the way, we're done with this. Okay, square root of 55. About what decimal is that? Well, I would say it's between, first of all, square root of 49 and square root of 64. So square root of 49 that equals 7. Square root of 64, that equals 8. So very, very generally right now we can say that the square root of 55 is between 7 and 8. Now how far is 55 from 49? It's about 6 away. So this is an increase of 6. And then how far is 55 from 64? That's 9 away. So if I considered how far between 7 and 8 the square root of 55 was, I'd say it's probably just, it's a little bit closer to 7 than it is 8. Because the square root of 55 is closer to the square root of 49 than it is to the square root of 64. So I'm going to guess it's about, let's say the square root of 55 is about, it's approximately, let's say 7 point, I'm going to guess 3. And I'll just throw in something else just for fun. 7.35. Let's see what it actually is. So, second square root of 55, 7.4. Okay, so I was off a little bit, but that's fine. I knew it was below 7.5 because it was closer to the square root of 49 than it was the square root of 64. And I hope that makes sense on square roots. If this video doesn't make sense after I'm done recording it, also I have a video up on there from Khan Academy, and that might do a better job explaining some things. Okay, so let's keep going. Fractions. You might see fractions in two different formats on these questions. You might see a fraction. Let's see if I can get a good example from the book. Here's some. Let's do this one. We did this one in class actually. So it talked about ordering these fractions from greatest to least. So you have 19 fourths. And again, this is a lot easier with a calculator. 19 fourths, 45 tenths, and here's so these are all improper, and here's just another fraction. 4 3/5. Okay? So, what you need to realize is, I mean, possibly, there's so many things you can do. When I look at this, I think I can write these much like this, which I would rather do. I had somebody in class say they would rather actually write 4 3/5 like this. 4 times 5 is 20, so you have actually 23 over 5. They said that they would rather write it like that. Whatever helps you sleep at night, I guess. I would actually rather write them like this. Okay, so I'm going to go ahead and write mine like that. So this one right here, so let's see. I'm going to go ahead and carry this down. 4 3/5. I'm good with that. 45 tenths is the same thing as 4 and 5 tenths. Okay, so pretty much what I'm doing is how many times does 10 go into 45 fully? So let's count it up. So we got 10, 20, 30, 40. So that's what that 4 is coming from, 40. We have 5 of the 10 left, so 45 out of 10. Okay, and same thing here. How many times does 4 go into 19? Well, 4, 8, 12, 16. So 4 times, and then 16, 17, 18, 19. Okay, I have 3 fourths left over. And this is actually what I'm comparing. So I have 4 3/4, 4 5 tenths, and 4 3/5. Okay, and what order are these going in front if I'm going to order them, you know, greatest to least? So it's really helpful to, again, have a calculator just because you can compute these. If you don't, you need to actually divide by doing something like this, like 3 divided by 4. But you got to go way back to elementary school or maybe middle school and think, oh, 4 doesn't go into 3, so add the 0, also add a decimal place, and then how many times does 4 go into 30? It goes in, you know, 7 times. 7 times 4 is 28. Subtract them, carry down to 2, and gosh, this has been forever since I've done that. Add a 0. How many times does 4 go into 20? 4 goes into 25 times. 0.75. So this is actually 4.75. But again, with a calculator, guys, you can just type it in like this. This is why I'm saying just get a calculator. 19 divided by 4, 4.75. It's nice and simple. But if you don't have a calculator, you might want to convert, doing